Now, for analysis of a storm, some of the things that you'll need a is the wave data and also the tidal data. So first off, to prepare that, we can use ERA5, our data on single levels from 1940 to present. This is a data set prepared by the ECMWF for analyzing weather. Now, the variables that we need for the wave data is mean wave direction, mean wave period, as well as significant height of combined wind and wave swell. And the storm Airwind happened earlier in 2025 in January from the 21st until the 28th. And technically, it only hit Ireland around the 24th, but we're taking the couple of days just to show normal levels, as well a day after to show normal levels after the storm. We do not need very high temporal resolution for this, so we'll only be taking every 3 hours now. So for the geographical area, I've already used Google Earth Pro to find the coordinates using place marks. As you can see, the place marks the coordinates can be quite rough. You do not need to have them be very precise. And additionally, you'll be able to see better, be able to see the wave data better with more rougher, larger coordinates like this. You'll be using grip format and it'll be unarchived because the request will be quite small. Now it'll be queued. You'll be able to download it in a couple of seconds. I've already prepared the file beforehand, so I don't need to download it again. So what I'll do is, to take a look at it, is I'll open up Delft 3D. Then in Delft 3D, I'll use Quick Plot, which is a one of the modules which is used for essentially visualizing data. Now I'll input the file. Files. This one. As you can see here, all 3 variables are available. And if we animate it, we can see the significant wave heights for the dates and the times that we've chosen. As can be seen here, as the storm hit Ireland, the wave heights significantly increased, and then they eventually settled down right after as the wave passed. Now taking a random part of the shore around here. Now here you can see approximately 24th of January is when the storm hit the hardest, and it continued with a dip here, possibly due to the eye of the storm passing over, and then it increased again, and then decreased again as the storm completely passed Ireland. Now, for the mean wave period, this can be seen. A larger wave period usually means that the wave has more energy, and then you can see 24th January, the exact same thing happened. More wave energy as the storm passed through decreased and then increased. and then eventually settle down into more normal levels of around 10 seconds. And the mean wave direction, so as can be seen, the wave direction was quite stable, and then as the storm hit, the waves came from a complete different direction, and as the storm passed, the wave direction returned to as normal. Now, for tidal data, you can use Delft dashboard. You can see here. So right around here is where Mannin Bay Blueway is. Using the Emartinet's Celtic Seas, their bathymetry, and using the UTM zone 29N as my coordinates around here. Now, unfortunately, there's no tidal stations closer to land. The closest tidal station is EAPSO number 30, 1136 IHO over here. Now, the start time has been set to 17th of January all the way to the 31st of January. This is done to show 2 weeks, basically showing a full cycle, full moon cycle. Here you can see on the left the spring tide, on the right another spring tide, and then right in the middle is the neap tide. As can be seen, the storm hit during the neap tide, which means that water levels, the waves especially, would have been much lower than it would have been during a spring tide. Exporting this is quite easy. All you need to do is, using the text format, export the tide signal, and this will appear in Delft dashboard's bin file right here, tech. And using quickplot again, the tidal signal can be imported in here and viewed. This one. Exactly the same as in Delft dashboard.